Okay, so in problem number 1, when simplifying this rational exponents, all we're going to do is multiply the exponents, right? Because the rule is if I have an exponent outside parentheses, I'm going to multiply that exponent onto each exponent inside parentheses. So the only exponent inside parentheses is a 4. So basically 4 times 3 over 2 equals 12 over 2. And 12 over 2 is what? 6. So this is really n to the 6th, and I'm done. So there is no square root if I simplify the exponents before I convert to roots. I could have converted to roots. I could have said the square root of n to the 4th raised to the 3rd. But that would be extra steps that I didn't need. Let's go ahead and simplify these exponents first, and then see if we need to go to square root to the root symbol. All right, let's go ahead and do this one. Again, this 5/3 needs to get multiplied by each of the exponents inside parentheses. So we're going to have 27 to the 5/3, and then p, 6 times 5 is 30 over 3 is 30 over 3, which is what? 10. All right? And you can see 6 times 5 over 3 equals 30 over 3, and that is 10. All right? So that's where the 10 came from. That's all I want us to do on this right now, because it's not telling us to simplify into the form of a root. Okay? Just want us to simplify those exponents. Now, you can probably put this in the calculator and it'll give you an answer. It will. It's the cube root of 27 raised to the 5th. It's probably some simple answer. I guess we can go ahead and do it since we are doing it. Okay, so 243p to the 10th is your simplified answers. So go ahead and, if you can, simplify. This is, this does not end up as a square root, all right, because it simplifies fully. All right, let's take a look at number 3. So number 3 is 25b to the 6th times raised to the negative 1.5. Now you can go ahead and put that in the denominator because you have a negative exponent. When we do that, it's 1 over 25b to the 6th to the 1.5.
Can we go ahead and multiply that out?
You can. All right, so when I do that, it's 1 over 25 to the 1.5. 25 to the 1.5. And then b to the 9th. Okay, can we simplify 25 to the 1.5? I think so. Just go up, just do 25. What was it?
125.
125. So 1 over 125 b to the 9th. 1 over 125 b to the 9th. All right, let's do the next one. 64m to the 4th raised to the 3 halves. So let's go ahead and distribute that 3 halves. So 64 to the 3 halves, m to the 12 over 2, which is what? 6. 4 times 3 over 2 is 6. You don't need to, we should know how to do that. We shouldn't have to write that out. 4 times 3 is 12. 12 divided by 2 is 6. That does not require you to show work. All right, so then put 64 to the 3 over 2 in the calculator and see what you get. 512. So 512 m to the 6th is the final answer. So, we're not ending up with any roots here. If you notice, that's because these are designed that way. All right, these aren't designed to end up with roots. All right, let's pause for a minute. Okay, so we've skipped down to number 9. You're not allowed to have negative exponents. You're not allowed to have fractional exponents in the denominator. So let's simplify. Now notice that when you're dealing with variables that are all the same base. They're all the same variable. All you have to do is add the exponents, right? So I'm going to be adding 2, 3/2, and -2. Also notice that in this problem, these exponents only go with the variables. They are not attached to the coefficients 2, 4, and 4. All right? Because there's no parentheses. So I'm going to multiply 2 times 4 times 4. That's 16 times, or 8 times 4, which is what? 32. So we know we're going to have 32 in front. And then m, and you add these up. Now, what happens when I add 2 and -2? 0. That's gone. What does that leave?
3 over 2.
3 over 2. Can I simplify that any further?
No.
Without using it, without converting to a radical?
No.
No, and I'm not converting these to radicals. Does it fit our rule? It says, or our conditions, our constraints, if you will. Does it fit that we have a positive exponent? Yes. Does it fit that we have no fractional exponents in the denominator?
Yes.
Yes, because we don't have a denominator. So yeah, this is good. All right. Again, you're not converting it into the root form or the radical form, but just because I'm telling you not to. All right. Look at 10. Again, we've got b's, so we're going to add these exponents. Now, your calculator will add fractions. Okay, it's not a big deal. Or you can do them off to the side. Well, first of all, you know you're going to multiply the coefficients. 3 times 1 is 3. All right. Then we need to deal with our fractions. So 1/2 is the same as. Let's hold on just a minute. Hello? Sure, I'll send him down. Thanks. All right, Dre. Go to the office. All right, guidance office. Okay, so we're going to take 1/2. We're going to convert it to a denominator of 6 because that's what our least common denominator is. So if I convert this to a denominator of 6, it's going to end up being 3 over 6. All right? 4/3 converted to a denominator of 6 is going to be equal to 8 over 6. Okay?
So it's going to be 11 over 6.
So it's 11 over 6. Now again, you're not having to simplify this into your radical form because I'm telling you not to. I just want the basic rational exponent simplified form. All right, look at 11. You've got to distribute or just multiply. -2 times 3 over 2. But it's a negative exponent. You don't want... So what?
Gotta flip it.
Okay, so you can go ahead and put it in the denominator, but then you're just going to have to flip it right back up. Let's just see what happens. All right. If you want to go ahead and put it in the denominator, you can do that. That's going to be p to the 3 over 2 raised to the 2. Okay, now what happens to the 2's?
They cancel out.
They cancel, so that's just going to be 1 over p cubed. So there are no fractional exponents in the denominator. All right? You could have gone ahead and multiplied these together. That would have given you p to the -3, and you just flip it down and it'd be 1 over p cubed. However, all right? Either way, it's fine. Okay, so let's go on to the next portion of this. Okay, it should be on the back side now. Okay, let's take a look at one like number 15. Alright, this looks super ugly. It looks really, really complicated, but it's not. Okay? Take it one little piece at a time. Work with the numerator, work with the denominator, and then if you have negative exponents, switch them around. Alright? Flip them up and down. I'm going to deal with my x's first. Alright, so I've got x to the -1/2, x to the 1/2. What happens to those? They cancel out. Laws of exponents. So those things are gone. Alright, which means I don't have any more x's. Because x to the 0 is just 1. So I've got a 3 y to the -1/3. Alright, over 3 y to the negative 7 over 4. I'm just taking this like one step at a time. Now, what happens to the 3's? They cancel out. Now I'm left
I got a question.
with y's.
Times the 3 times 3.
Say what?
3x times the 3x.
Well, it's x to the negative 1/2 and x to the 1/2. When you're multiplying powers with a common base, you're going to add the exponents, right? So that's why they cancel it out. But the 3's don't cancel out. The 3's are separate. They don't go along with the laws of exponents.
So where the second 3 goes?
Yeah.
3 times 3 is 9. I missed that. That's the point. Good job. All right. All right. So then this should be a 3 up here because 9, 3 goes into 9 3 times. All right. So now we do have a 3 still there. Now, if you want to, you might make it easy. Just put both y's in the numerator. In other words, don't flip these things around using the laws of negative exponents and then have to flip it right back. We need them next to one another. So I'm just going to take the one that's in the denominator and move it up here and see what happens when I add the exponents. So I'm going to have 3y to the negative 1/3 times y to the positive 7 over 4. You see what I did? Just moved it up. Took the negative exponent that's in this denominator and moved it to the numerator, and that changes the sign. Now we need to add these fractions, and you need a common denominator and all that good stuff. The calculator will do it. Look, if you want to do it fast, go to alpha y equals, press enter on number 1, and then just plug them in. So you got negative 1 over 3
Do alpha y.
plus alpha y equals, and then 7 over 4,
Alpha y equals.
and press enter, and it comes out to be 17 over 12. So
Coach, can you show me that one more time?
3y to the 17 over 12. All right, press alpha,
Okay.
y equals,
Okay.
enter on number 1, and it's
Okay.
fraction. Okay?
Coach, I put
Yes.
the same thing and I got 7.
All right, negative 1/3 plus 7 over 4. Yeah, plus 7. You're adding these two things right here. All right, so it looks ugly, but if you just follow the laws of exponents, and that's what we're trying to do, and that's what our goal is, to use the laws of exponents to simplify these things, then it's not as ugly as it appears.